Okay, welcome. In this short video lecture, we're going to illustrate how we can use Laplace and inverse Laplace transforms to solve a system of differential equations. So here's the problem. I've been asked to find the solution of the initial value problem. X prime plus x plus a half y prime equals to 1. And a half x prime plus y prime plus y equals to 0. Subject to the initial conditions, x at 0 is 0 and y at 0 is 0. So the key thing or the starting point is to rewrite the derivatives and the functions in terms of the Laplace transforms, and then reconvert the Laplace transforms into the corresponding inverse Laplace transform to get the expression for the function x of t and y of t. So this is how I'll start. So solution, let capital X be the Laplace transform of x of t, and capital Y of s be the Laplace transform of the function y of t. And we know that Laplace transform of the derivative of x will be given by s x of s minus x at 0, and Laplace transform of y prime is given by s capital Y of s minus y at 0. So therefore, once we know this from definition, then because we have been given initial values here, so the same thing as just saying this is the same as s x of s, so this is 0 from the equation, and this is s, because this y at 0 is 0, x at 0 is 0. So then supply Laplace transform on each equation, i.e., so I'll say Laplace transform of x prime plus Laplace transform of x plus Laplace transform of a half y prime equals to Laplace transform of 1. And then the other one will be Laplace transform of a half x prime plus Laplace transform of y prime plus Laplace transform of y equals to Laplace transform of 0. So using the definitions given here, so this will be replaced by s x. So this is like my equation 1, this is my equation 2. So 1 becomes s x of s plus x of s, and then plus a half, this one is the same as y of s, and then minus y of 0, which is just 0. So, and then equals to Laplace transform of 1 is 1 over s. And then the other one will have a half s x of s, and then plus. So remember, this is s, because we have s y of s. And then this one is given by s y of s, and then plus y of s. Laplace of 0 is 0 from here. So this number was obtained from 1 this is from 2. So let's call this one 3. Let's call this equation, let's call it 4. Now, from 3, you see that we can put this together so that I have s plus 1, capital X of s, plus a half s, and then capital Y of s equals to 1 over s. And then this is a half s x of s plus s plus 1 capital Y of s equals to 0. Bring this term and this one closer. Let's call this one 5. Let's call this one 6. Now, this simply simultaneous equation in terms of capital X and capital Y. So I can say this system can be written as s plus 1, a half s, and then a half s, and then s plus 1, and then capital X of s, capital Y of s is given by 1 over s, 0. This is writing this system in matrix form. So using Cramer's rule, you can use any other method that you know how to solve system of linear equation, system of 2 linear equations. So using Cramer's rule, we see that y of s will be given by determinant of s plus 1, a half s, and then 1 over s, and then given by this is 0 over the determinant of this matrix s plus 1. This is 1 over 2s, and then this is 1 over 2s, and then this other one is s plus 1. This determinant, which when you work out, this will give you negative a half, and then over this other one will be s plus 1 squared minus s squared over 4, which on simplification is the same as negative a half into 1 over 3 over 4 s squared plus 2s plus 1. So that is what we get as our y. So y of s is the same as just negative a half. So I can rewrite this one as 4 over 3s squared, and then plus 8s, then plus 4. This is not hard to actually convert this one into this form here. So which is the same thing as saying this negative a half into 4 over, now this a quadratic, so product 12 sum a, so we can always factorize this one as 3s plus 2, and then this other one will be given by s plus 2. And then, so y of s is negative a half. I also use partial fractions to decompose this one as a over 3s plus 2 plus b over s plus 2. And when you work out comparing, so remember this this part is the same as 4 over s, 3s plus 2, and then s plus 2 equals to a into s plus 2 plus b into 3s plus 2 divided by 3s plus 2 into s plus 2. So it tells you that 4 is equivalent to A into S plus 2 plus B into 3S plus 2. This is just playing with partial fractions. So when you set S to be -2, so we'll have 4 equals to -2 by 3 is -6 plus 2, -4 minus 4B. So this tells you that B equals to -1. And then when you set S to so make this one, so S 3S plus 2 equals to 0. So S equals to -2 over 3. So -2 over 3. Then we have 4 equals to -2 over 3 A plus 2. So -2 over 3 plus 2, the same as -2 plus 6, which is 4 over 3. So 4 over 3A. So it tells you that A will be the same as 4 times 3 over 4, so which is 3. So therefore A equals to 3. Thus, capital Y of S is given by A, which is 3. So we have -1/2. -1/2 into 3 over 3S plus 2 plus B, which is -1/2. So you just put negative. So we have -1 over S plus 2 S plus 2. So this is what we have. And then this same, so next we apply inverse Laplace transform on both sides of this one here, so that we have inverse Laplace transform of capital Y of S is -1/2 inverse Laplace transform of 3 over 3S plus 2 -1 over S plus 2. So which is the same thing as, so this will be now Y of T equals to -1/2 inverse Laplace of 3 over 3S plus 2. Now minus will be +1/2 inverse Laplace transform of 1 over S plus 2. So for this one to take the standard form as 1 over S plus a constant, then it can be written as Y of T equals to -1/2. So I divide each term by 3 so that I have 1 over S plus 2 over 3, and then plus 1/2 L inverse 1 over S plus 2. So then now this one and this one are in standard form that we can actually read their Laplace transforms. So Y, therefore Y of T will be -1/2. This will be e raised power minus 2 over 3 T, and then plus 1/2. This will be given as e raised power minus 2 T, which you can rearrange it as 1/2 e raised power minus 2 T minus 1/2 e raised power minus 2 over 3 T. So this is the function Y of T. And then similarly, X of S, when you use still the same Cramer's rule, you'll get the answer to be 4 into S plus 1 divided by S into 3S plus 2 into s plus 2. And actually on decomposing into partial fractions, you'll be able to get, so know that the form s over a over s plus b over 3s plus 2 plus c over s plus 2. And when you do the same thing that you have done for y, you'll get that a will give you 1, b will give you 1, a half, negative a half, and c will give you negative a half still. So that you have x of s will give you 1 over s minus 1 over 2 into s plus 2 over 3, and then plus, minus, not plus. So minus 1 over 2 into s plus 2. So that so when you work out this one, this will be this 2 will not be negative a half. So work that one and then confirm the solution. So 2 into s plus s over 3. So this will give you 3 over 2 minus 3 over 2. So that now this is what we have as your x of s. So then applying inverse Laplace transform. So we'll have inverse of 1 over s minus inverse of 1 over 2 into s plus 2 over 3 minus inverse Laplace transform of 1 over 2 into s minus plus 2. And therefore, this one is all these are the standard ones, so just factor out a half and then a half here, then you can always read the values. So x of t will be given by 1, this will be 1, minus a half, e raised to power minus 2 over 3 t, minus this will also be a half, e raised to power minus 2 t. So therefore, this is the value for x of t. So that is how we solve system of differential equations using knowledge on Laplace transform and inverse Laplace transform. So thank you.